Okay, the next part of our lesson is going to be how to balance chemical equations. Now, several different people teach this several different ways. I think my way is pretty easy, a lot easier than some of the other teachers, so I'm going to do it this way. If you find an alternative method that you like from watching other videos, feel free to use it. Okay, now this way doesn't work all the time, but I'd say 95% of the time it works pretty well. So I'm going to start with the ion that's closest to the arrow on the left side. Like I said in the last video, we're going to ignore the G's. They just stand for the state. Okay, so I have two Cl's on this side, two chlorines on this side. So I have to get the same amount on this side. So I'm going to put a 2 in front right there. Now, that changes the number of H's. 2 H's, 2 H's. So it should be balanced because I have the same amount on both sides. 2 H's, 2 H's, 2 Cl's, 2 Cl's. Now this 2, this coefficient, distributes to both of those elements, just like we talked about earlier in the semester. Okay, next example. I have 2 O's on this side and 3 O's on this side. So we're going to ask ourselves, what's the least common multiple between 2 and 3? And it should be 6. So to get 6 right here, we're going to do 3 times 2, gives you 6. And I'm going to put a 2 right here in front. So that's going to change your number of aluminums. 2 times 2 is 4. So I have to stick a 4 out in front right here. Okay, next example. I'm going to start with the oxygens. 2 oxygens here. I need to get 2 on this side. So I'm going to put a 2 in front right there. That changes your number of hydrogens. 2 times 2 is 4 hydrogens. So 2 times 2 gives you 4 hydrogens on this side. And we fill in the 1. Like that. Okay? Now, next example. We have 2 hydrogens on this side and 3 hydrogens on this side. So the least common multiple between 2 and 3 is 6. So we're going to put a 3 right here. 3 times 2 gives us a 6. And I'm going to put a 2 right here. 2 times 3 is 6. Now, this changes the nitrogens. 2 nitrogens here, 2 nitrogens here, and it should be balanced. Okay, now we're going to get into stuff that looks a little more complicated, but it's really not. Now, we learned ions for our second test, and being familiar with them helps us on this type of example problem. So, I'm going to start with the ion that's closest to the arrow on the left side. So I have 1 I on this side, 2 I's on this side. So I need to change this to 2. Okay, that changes the amounts of K's. 2 K's here, I need to put 2 K's on this side. 2 K's there. 2 nitrates, NO3 is the nitrate group, so we're going to keep it together. So 2 nitrates here, 2 nitrates here. 1 PB here, 1 PB here. So it should be balanced like that. Next example. CO3 is the ion I'm going to start with. So 1 CO3 on this side, 1 CO3 on this side. That's not going to do me any sort of good. Okay, so let's move out 1. 2 NAs on this side. I need to get 2 NAs on this side. So I'm going to write a 2 right there. That changes your nitrates. 2 NO3s, 2 NO3s. 1 Ca, 1 Ca. So it should be balanced. We just fill in the 1s. So, next example. We have 2 nitrates on this side, NO3 is nitrate, and we have 3 nitrates on this side. So the least common multiple between 2 and 3 is going to be 6. So we're going to put a 3 right here, and a 2 right here. Now, that changes my BAs. 3 BAs, 3 BAs, 3 SO4s, 3 SO4s, 2 ALs, 2 ALs, 3 SO4s, 3 SO4s. So everything should be balanced. Okay. Now, when we start doing things that deal with water, it might be beneficial if you break water down to read like this, H and OH. Okay? So we do H and OH. This is a hydrogen ion. This is a hydroxide ion. Okay, so we're going to start with the hydroxides. 1 OH on this side, 1 OH on this side. That's not going to do us any good. we're going to go to NAs. 1 NA, 2 NAs on this side, so I need to double this. So 2 NAs here, I need to get 2 NAs there. 2 OHs, I need to put 2 OHs. 2 hydrogens, 2 hydrogens, 1 sulfate, 1 sulfate. So it should be balanced from there. Okay, just words of advice on this. Do it in pencil. You're probably going to mess up a few times. You just got to work a lot of questions. Okay. Next question. CO3s. I'm going to start with that one. So CO3s, carbonate. I have 3 carbonates on this side. The carbonate group doesn't appear on this side. Now, what I can do here is I can say that I have 3 carbons because this distributes to each of those terms. So 3 carbons here, 3 carbons there. Now, I have 9 oxygens on this side. 3 times 3 gives you the 9. I have 3 times 2 is 6 right here and 3 right here. So I have 9 total on that side. So this would be balanced. Next question. It deals with water. So I'm going to try and break this water down to HOH, just like we did in the previous example problems. Okay, so I'm going to start with my OH ion because it's closest to the arrow on the left side. Okay, so I have 1 OH on this side, 2 OHs on this side. So I need to put a 2 in front right there. 2 hydrogens, 2 hydrogens. 1 SR, 1 SR. So it should be balanced now. Okay, this one deals with water, so I'm going to break it down to HOH. Okay, so I'm going to start balancing with the hydroxides, the OHs. So I have 2 OHs on this side. I need to get 2 OHs on this side. Now, that's going to change my hydrogens. 2 hydrogens here. I have 3 on this side. So that's going to... That's gonna mess everything up. So I'm gonna start over. I'm gonna figure something else out to balance first. Okay, so let's start, let's go with PO4s. Okay, so I have 2 PO4s on this side. I need 2 PO4s on this side. 6 hydrogens here. I'm gonna put 6 hydrogens here. 6 OHs, how do I get 6 OHs? Well, I multiply this by 3. 3 MNs, 3 MNs. It's balanced. Okay? So it's a little tricky. It doesn't always work out perfectly the first time, so you just kind of got to know what to deal with. I would start with negative ions first. It always works out a little bit better with that. Now, this is a special type of equation. It's called a combustion equation, and we're going to learn about it. The word combustion means that something's going to burn. Fancy word for burning. Now, you know it's a combustion equation when you have a hydrocarbon, which means it has carbon and hydrogen in it, plus oxygen. That always gives you carbon dioxide and water. Now, there's a specific way to balance a combustion reaction. We start with carbon first. So you have 2 carbons here, you put 2 carbons there. Hydrogens is what you balance next. You got 6 hydrogens on this side. I need to put 3 right there because 3 times 2 gives you 6. Now the last step is we're going to go through and we're going to count our oxygens. So 2 times 2 is 4 plus 3 is 7. Okay. Now anytime you get an odd number of oxygens on this side, you have to multiply it by 7/2 like that. Okay, because 7/2 times 2, 3.5 times 2 gives you 7. So it's balanced. Now, what we like to do in this case is we have to have whole numbers. So we're going to end up doubling everything to get rid of the 2. So it's 2, 7, 4, and 6. Now, as you work through these problems, we're probably going to have to do a few more combustion ones, and that's fine. When we get through the worksheets, if you have any questions on these, I can rework some. And when we get to the combustion section of our reactions, I can work plenty going through that section. Okay, if you have any questions about this, I need you to email me or text me. Hopefully you have a good night, and I went slow enough to where you understood this. You have plenty of practice problems and answers attached in Blackboard. Hopefully you have a good night. Thanks.